Hey guys, good morning and welcome back to my channel. Hope you guys are good. I am feeling good. Everything is great. We are doing a JavaScript deep dive series. We have some time. You are here. Let's just get into it. Why do I prefer to record my videos in the morning? Because morning I think I have a little less clutter and I have more clarity. But the main thing is कि घर में ज़्यादा आवाज़ नहीं हो रही होती, so I can record in peace without pausing and stuff. प्लीज़ आई अपोलोजाइज फॉर माई वॉइस. सुबह मेरी आवाज़ ऐसी ही होती है. ओके, सो दिस वीडियो आई वॉन्ट टू मेक इट अबाउट स्कोपिंग, lexical scopes, lexical environments, closures. बट सम ऑफ यू इन द लास्ट वीडियो वर कि यार तू ना थोड़ा बेसिक लेवल पे, एक बिगिनर लेवल पे नहीं बताता है चीज़ें. And which can be true. I tend to drift off. So that is why I wanted to go one step backwards. I wanted to get deep into what hoisting really is. And to get deep into what hoisting really is, I need to explain execution context better to you all. And uske baad maybe we can move into what a scope is, lexical scopes, environments, scope chains and stuff like that. So this is still where we had done the last time. This is what we'll touch base today. What is hoisting really? So what is it really? So this is a very interesting concept because, for example, when a question has a very complicated answer or not a very simple answer to give, so we generally give abstract answers for it. Those answers might not be physically what the actual thing is happening, but they just give a general overview to describe the phenomenon. जैसे कि भाई हम मम्मी पापा से पूछते हैं कि ऐसा क्यों होता है, तो उनको पता होगा, बट ऐसे पता होगा, समझ तो आएगा नहीं इसको, तो बोल देते हैं क्यों का कोई जवाब नहीं होता. सो ऐसे ही इनफॉर्मली व्हाट होइस्टिंग इज. सो होइस्टिंग इज एन ऑब्जर्व्ड फिनोमिनन. It is an observed phenomenon. Why observed? Because your variables and functions appear to have moved to the top before their actual declaration and initialization. Why do I say observed? Why do I say move? Because a person can observe that, for example, on line number 10 I have declared a variable and initialized it, but if I try to access it on line number 5, the code will not give an error. It will cause some unexpected things, but the program will not stop executing. So this is observed. Even though I've declared it at line number 10, but I'm able to access it at 5. That means somehow before the code is being run, my code is being moved to the top. So it is an observed phenomenon. But what really is happening, what actually is happening such that you are able to access your variables or functions before they are declared or initialized, is due to the execution context. What is the execution context? In the last video as well, I told you that the JS engine internally has two mechanisms. It has two physical aspects. One is the call stack and one is the heap. Okay, quick refresher. What is a heap? Heap is just an unstructured memory pool where your application's non-primitive data type lives. Non-primitive data types, your objects, arrays, functions, these live in the heap. What is there in the stack? Stack is where the actual code execution, the JS engine is actually executing your code in the call stack. Also, your primitive data types such as strings, numbers, booleans, etc., they live on the stack, as well as the references to your heap ka data. Let's not think about that. Call stack mein, let's see it like that. The main purpose of the call stack is to execute the JS code. Just a second. A lot of programming languages have call stacks. I mean, in every programming languages, for a code to execute, they need a call stack. So call stack in very simple terms is a place where JavaScript engine will execute your code. Now, how this code execution is done? The call stack needs the help of execution contexts. It needs the help of execution contexts. Okay, so what are execution contexts? It is just an environment. It is just a wrapper environment. For example, the call stack encapsulates your code into an environment, and it is like कि इस environment के अंदर I will do the actual code execution. For me to actually execute the code, I need to first wrap it in an environment. So इस environment को, इस wrapper को, इस encapsulated जगह को we call the execution context. Okay, very simple. It's just a wrapper. There are further branches. How simple? There can be two types of execution context. Very simple. Two types of execution context. One is a global execution context and one is the function execution context. Why a function execution context? Because the JavaScript engine has laid some rules that whenever you are parsing the code and you see a function invocation, I want you to create a separate environment. I want you to create a separate encapsulation for that, and that separate encapsulation is called the function execution context. It is also the same execution context, but we just label them differently. For your top level code, which is not nested anywhere, we have the global execution context. Okay, so let's also see. It's the environment which the call stack creates for actual code execution. Two types of environments: global execution and function execution. Nothing too fancy. Visualize this. For your top level code, a global environment wrapper or a global execution context is created. So first and foremost, it needs a global wrapper. All of your code lives in a JS file, right? So thinking like this, JS file is like the wrapper for all of your JS code. So call stack में for your top level code, there needs to be a global environment which is called the global execution context. Functions cannot be executed inside this global environment or global execution context. They need a separate environment for themselves to execute the code present inside it. Why? What was the need of a separate execution context? Because functions are like, they have their own set of variables, they have their own declarations, they have their own custom logic. So the JavaScript engine is like, okay, you create a separate execution context for the function itself. Understandable. Hence, this separate environment that the functions need for themselves to execute is called a function execution context. ठीक है. Next steps. So the thing is, call stack has laid the rules कि भाई, for me to execute the code, I need an execution context. So it creates the wrapper. But just creating the wrapper is not enough. There are some more set of activities that actually happen. So even though the wrapper is created, it is not set up. It does not actually yet contain any useful information that we can use to actually execute the code. So there is a setup phase for the execution context and there is an execution phase, the code execution phase. The call stack will only create that wrapper, but internally there will be two things that will happen. One is the creation phase and the other is the execution phase. The execution phase is interesting. So what is happening? Let's go back to the previous lecture. Before actually executing the code, our JS engine, what it does, it parses your code. It it performs legsing, where it is splitting your source code into tokens, let, const, var. then it is parsing those tokens to create the AST, then it creates the bytecode and stuff like that. So this is exactly what the creation phase is. Either the JS engine would have already created this AST, or if not, it will dynamically create this intermediate representation. So while it is creating the intermediate representation, what it is doing, it is registering our values, our variables, all the declarations that we have made. It registers them and binds them with some value. It registers, it creates a mental model of all the declarations that you have made, and also it assigns it with some values. For example, for functions, it will assign it with the function body. For variables, it will assign it. For the var variable, it will assign it with the undefined. So this is all what is happening in the creation phase. Now let me tell you. So the JS engine bounded some values to register the declarations. So this process where the JS engine actually bounded the values, registered the values, is called as or leads to hoisting. This actual thing which the JS engine did, to the user it seems like my code moved to the top. No, the JS engine in the creation phase registered your declarations with some bounded values. That is why you are able to access your code before it was initialized, because as I said, before running your code it is doing the creation phase. तो यहाँ रन करने से पहले अगर आपने वेरिएबल यहाँ डिफाइन कर रखा है, तो क्रिएशन फेज में तो ऑलरेडी इंजन ने उसको एक रजिस्टर्ड वैल्यू दे रखी है ना. यूजर को लग रहा है कि अच्छा इट मस्ट हैव मूव्ड टू द टॉप, इट मस्ट हैव होस्टेड, बट इन रियलिटी दिस इज व्हाट द जेएस इंजन इंटरनली इज डूइंग. The environment has been created but has not been set up yet. Create किसने किया? Call stack ने. Set up क्या करेगा? JS engine. Sets up the environment for code execution. What is setting up the environment? It needs to scan and register what all variables and functions are present inside this context. Inside this execution context, what are the variables and functions present? The JS engine collects all the declarations, these are declarations, to create bindings for them in that particular scope. We'll come to scope later. Engine level story. Engine has to parse the code to know what's declared. The engine generates the bytecode to set up the environment bindings. Environment binding कैसे होगी? जब आपका बाइट कोड जनरेट होता है, जब आपकी इंटरमीडिएट रिप्रेजेंटेशन जनरेट होती है, उसी में आपकी बाइंडिंग्स क्रिएट होती हैं. वार वेरिएबल की अनडिफाइंड, फंक्शन के लिए बॉडी मिल जाती है. दैट इज व्हाट हैपेंस. दिस क्रिएटिंग्स ऑफ बाइंडिंग्स फॉर द एनवायरनमेंट्स results in var variables being registered with undefined functions getting their body allocated. So this result of the binding phenomenon is termed as hoisting. Your variables are not literally being moved to the top by the compiler. This is something scanning, registering and binding the values is being done, which results in code appear to be have hoisted. So hoisting is not an actual operation which gets performed. It is the overall result of a set of activities which are being performed in the creation phase to set up the environment. So for those of you all who are saying that hoisting kya hai, so maybe now you are comfortable what is really happening below the surface. How hoisting is different for let and const. So the var keyword has its shortcomings. So in the creation phase, the JS engine was binding var with the undefined keyword, and that is why you are able to access it. But is actually accessing a variable before it is actually defined a good thing? It might really depend on your use case, but generally in most of the scenarios, it is not a good design pattern where you are able to use your variables before they are even declared. At least in the server side programming, it's not a good design choice. So in light of those shortcomings, the ECMA organization was like, let us introduce a new kinds of variables, let and const, which is different from the behavior like var exhibits. How different? In the creation phase, when the JS engine is creating bindings for your let, for your var function, if it encounters any let and const variable, it will not bind those variables with an undefined value. Var may it was bounded with the undefined, so you were able to access it, you were not getting any error. Let and const may the JS engines hoists, it is registering those variables, but it is not binding it with undefined. It bounds it with something called as the TDZ, or the temporal dead zone. Now this is very interesting and very simple as well. This temporal dead zone is just a way of saying that if you try to access this variable before it is being initialized and declared, I will throw an error. Like most of your other languages like Java and compiled languages do, if you try to access a variable before their initialization, they will give an error. So exactly this TDZ is responsible for giving you errors. If you try to access let and const before their initialization, it will give you a reference type error. Not the optimal approach. It could lead to unexpected behavior. It could lead to unwanted bugs due to pre-initialization of variables as undefined. To overcome these shortcomings, ES6 release में ECMA release let and const, they would still be hoisted in the creation phase, but rather than being bounded with the undefined value, they are kept in the temporal dead zone. This temporal dead zone will ensure that if these variables are being accessed before their actual initialization, an error is thrown. Which error? A reference error. This made the variable behavior more stricter, hence more predictable. So the thing is, the more stricter you make a language, the more number of rules you apply, the more predictable it becomes. So it's really use case driven. If you want your code to be very predictable, then you use this. If you want maximum flexibility, then JavaScript already has the var variable. It also has a global variable. The execution phase, the meat of the execution context, which all have you been waiting for. भाई तूने इतनी कहानी बता दी, ये हो रहा है वो हो रहा है, अभी तो कोड एग्जीक्यूट होना शुरू भी नहीं किया. तूने तो पुल बांध दी है कि भाई फास्ट एग्जीक्यूट हो जाती है, ये हो जाती है. अब घंटे हो गए कोड एग्जीक्यूशन ही नहीं हो रहा, तो कर देते हैं एग्जीक्यूट. The execution phase. Now that the call stack has created the environment and the creation phase has set up the environment, the JS thread will execute. It will execute the bytecode that is being made. That is what happens. Now everything is ready. The dinner has been served. The only thing is left to eat and enjoy. The actual code will start getting executed line by line. Okay? Assigning values to variables. In the creation phase, the JS engine registered your var functions with bodies undefined, let and const with TDZ. Now, while running, it is doing the actual value assignment. It is doing the actual value assignment. var को उसकी value देना, let and const को उनकी actual values देना. This is happening. Executing functions and code blocks. Code blocks. For example, it is executing those functions. As I mentioned, execute करते हुए, for example, console.log something, x equal to something, some arithmetic operations are being performed. But as soon as it meets a function invocation, it will stop right there. It will create a new execution context for it, and it will repeat the same process for that execution context, execute it, and then only move back till here. Okay? So it is just how JS engine is defined, a call stack is defined. It ऐसे ही बाकी languages में भी ऐसे ही होता है. आपके functions के अंदर जब दूसरे functions invoke होते हैं call stack में, एक नया एक वो बनता है. JavaScript में execution context कहते हैं, बाकी languages में पता नहीं क्या कहते हैं. The JS engine is single threaded in nature, and it will move its thread to the newly created execution context and will repeat the same story again. Components of execution context. भैया ये तो ख़त्म ही नहीं हो रहा. आप लोग कहोगे अभी तूने बताया एग्जीक्यूशन कॉन्टेक्स्ट एक रैपर है, फिर तुमने बताया उसके भी दो फेज़ होते हैं जिसमें मेमोरी क्रिएट हो, जिसमें तुम्हारी चीज़ें क्रिएट हो रही हैं. एक फेज़ है कोड एग्जीक्यूशन वाला. अब कंपोनेंट्स भी होते हैं. Components are just an abstract way to represent these two phases. For example, जिसको इतना डिटेल में जाके नहीं बताना है और उसको थोड़ा structured करके, he wants to structure the thing and explain. What he will do, he will say that execution context has two phases. It's divided into two components. In one component is the memory component where the creation phase is taking place. One is the code component where the code execution is taking place. But do these components actually physically exist inside the JS engine, inside the call stack? No. We just do a separation of concerns to make it understandable to the users, to the learners, कि भाई the creation phase is happening inside the memory component and the code execution is happening inside the code component. They are just teaching abstractions over the actual phases. It's just a way of mapping the creation phase to the memory component. ये undefined मिलना, function को body मिलना, हम कह रहे हैं कि ये एक memory component के अंदर हो रहा है, ठीक है. And the execution phase को हम map कर रहे हैं with the code component कि यहाँ पे each line of the source code is being executed line by line. They don't have a physical presence. It's easier to represent. आपने चित्र देखा होगा तो आपको लगा होगा चाह ऐसे होता है. It's just easier to represent the creation and execution phases by boxing these concepts into components. Concepts. Oh, the call stack. So this is the last phase of your learning thing in execution context. कि चलो, the call stack is creating these execution contexts, but how are they being managed inside the call stack? So this is just like, have you seen a pile of books lying around? They are stacked on top of each other, and you can only take out the last one that you took. It's last in first out, or first in last out. That is exactly how the call stack manages your execution context. It has a stack. It stacks them on top of each other. For example, when your code starts executing, it creates a global wrapper or a global execution context. Okay, inside this, when a function is invoked, it creates a new execution context. It stacks it on top of the execution context. उसके अंदर भी कुछ function execution होगा. It will again stack it on top. So there is a stacking of execution context being done. है ना? And the last execution context that created, when it is fully completed, only then will our thread pop it off from a stack and move to this. Create it, complete it, pop it, and then move here. And then when finally your everything is done, everything inside the top level code has finished execution, there is no need for a global execution context itself. So the call stack will pop the global execution context also, and your application will be terminated. So that is the whole life cycle. Let's see diagrammatically. Ever seen a pile of books stacked on top of each other? If yes, then you're already halfway there. It's a data structure. JS engine executes the code with the help of ECs. They are stacked on top of each other inside the call stack. First thing first, a global environment or a global execution context is created and stacked on top of the call stack. Okay, the call stack was initially empty. It saw the top level code and it was like, I need to create a global wrapper. It created a global execution context. Inside this execution context, inside the code execution phase, whenever there is a function invocation, a new execution context will get created, which is again stacked on top of the stack, like this. इसके अंदर फॉर एग्जांपल ग्रीटिंग्स का इन्वोकेशन हुआ तो इट क्रिएट्स अ न्यू एग्जीक्यूशन कॉन्टेक्स्ट एंड इट विल स्टैक इट ऑन टॉप ऑफ द हियर. नाउ द JS thread will not continue with the execution here, it will move here and it will complete this. ठीक है, it will complete its execution. When this execution context is completed, its execution is completed, it will pop off. This execution context will run its own creation and execution cycle, and once it's done executing, it will get popped from the stack. It gets popped. Now we are again left with global execution context. उसके बाद भी देयर कैन बी सब्सिक्वेंट फंक्शंस कॉल्स. ऐसा थोड़ा ना कि आप एक ही फंक्शन कॉल करते हो, जितनी बार भी आप फंक्शन कॉल करोगे एक नया एग्जीक्यूशन कॉन्टेक्स्ट बनेगा जो अगेन इसके ऊपर स्टैक हो जाएगा. हो सकता है इसके अंदर एक और फंक्शन कॉल हुई हो तो इसके ऊपर एक और आ जाएगा, है ना, इसके ऊपर एक और आ जाएगा, इसके ऊपर एक और आ सकता है. तो इट इज़ रिकर्सिव एंड जब तक टॉप लेवल वाला ख़त्म नहीं हो जाता एग्जीक्यूट करना, द थ्रेड विल नॉट मूव बैक टू वेयर इट स्टार्टेड. When this two is done, we can pop from the global stack. And मान लो कि अब global जितने भी top level code था, it has finished executing. So after that, even the global execution context gets popped off from the call stack, and this is where your application terminates. Pew pew pew, खत्म हो गया. You can see it followed a first in, last out, or last in first out terminology. जब आप बुक्स को एक दूसरे के पास स्टैक कर रहे हो तो आप क्या करोगे, सबसे ऊपर जो किताब रखी हुई है वही पहले निकाल सकते हो. आप जंगा नहीं खेल रहे हो कि बीच से आपने किताब निकाल ली और स्ट्रक्चर हिला नहीं है आपका, जंगा नहीं है. आपने किताब रखी एक दूसरे के ऊपर, आप लास्ट वाले निकाल सकते हो. उसको जब निकल जाए फिर ये निकालो, फिर ये निकालो, फिर ये निकालो. सो आई थिंक एग्जीक्यूशन कॉन्टेक्स्ट, होइस्टिंग, क्रिएशन फेज, execution phase, all of this is clear. Now I think we can move to scopes. What scopes are?